Imagine a world where we have superpowers. A world we can control without touching. Wave your hand and life suddenly becomes easier. Now we introduce to you the Gesture Virtual Interaction System. The intention of GVIS is to make the interaction between human and machine as natural as possible. We test this concept by implementing a virtual mouse. It can perform most operations like a regular mouse, but in a more interactive way. GVIS includes two major programs. The first one is a 3D render program, which is written using Python and OpenGL library. The other program is used for gesture tracking and recognition. For gesture tracking, we use color-based object tracking. And for gesture recognition, we use YOLO v5, which is a PyTorch-based neural network model. This 3D rendering software is capable of loading and rendering 3D objects with more than 1 million of vertices and triangles while maintaining a good frame rate. This is achieved using Python and OpenGL shader programs, which allows us to take advantage of GPU's processing power. Color detection-based GVIS allows users to control the 3D rendering software using hands. To enable color detection, a distinguishable color band must be used. GVIS will then constantly look for and track the colored contours that it finds in the image capture. Then it will simulate the mouse and keyboard events based on hand movements. Gesture interaction is built on top of color detection-based GVIS. Object detection runs in parallel with the tracking process. To be able to distinguish different gestures, we trained a set of weights for YOLO v5 model. The collected datasets are from different sources to avoid overfitting during the training process. Thanks to roboflow.com, we were able to expand the dataset to 1,600 images. Using its augmentation functions, this hugely improved our neural network training result. At this stage, the project has achieved our expected deliverables. It is a proof of our original concept. However, we believe it can go further. We will keep expanding the dataset to increase its accuracy under different lighting conditions. We are also working on connecting the system to depth cameras, which will add another dimension to the user operations, bringing a lot of advantages to the object detection process. An API will be added. We wish app developers will find different ways of using GVIS for their applications and further expand the usage of virtual interaction.